Welcome to Digital Works TV. I'm Steve Johnson with a very special guest, Norm Tew. A lot to talk about. I'm going to have to read this, Norm. I remember some of it. You're retired from Boeing. You're an electrical engineer, an Auburn graduate.
Right.
When you left Boeing, you were the vice president of and general manager of missiles and weapon systems at Boeing. That everything Boeing was doing when you were there in missiles and weapon systems, you were in charge of that. Before that, when you and I have done interviews in the past, you were the VP and program director for GMD, the ground-based mid-course defense.
Right.
Our defense against intercontinental ballistic missiles.
Correct.
And Boeing was the chief contractor, and you were in charge of all the stuff Boeing was doing, and that included training. They had a whole training setup out there that you were doing for people operating that. Okay, before that, you've had other jobs, including being the chief systems engineer for THAAD, Terminal High Altitude Area Defense.
Correct.
And you're working for Lockheed Martin. So
Right.
you have been in the engineering world and the defense aerospace engineering world for a long time. And you were a systems engineer.
Right.
Which just is right up our alley.
Okay, good.
I want to talk a little bit about, working with GMD. I just decided to pick that because, in systems engineering, everything is a system. I mean, this pen is a system.
Right.
But the GMD was an incredible example of a system with lots and lots of parts, and none of it would work if every single part didn't work.
That's right.
And I mean, they were complicated parts,
Yes.
or still are, I suppose.
Yes.
Talk a little bit about that, you just can't look at any one part of it. You have to look at the whole thing, and every systems engineer knows exactly what that means.
Yep. Yeah, and in fact, it's a great example of systems engineering. It is a system of systems. So let me describe a little bit about how it works, and then that'll help with some examples of what does a system engineer do in like a program like GMD. So as you mentioned, GMD is in fact it's the nation's only defense against long-range nuclear ballistic missiles incoming. And so to make something like that work, think about it from one site. In fact, we have 2 sites with interceptors in it. From that 1 or 2 places, you've got to defend the entire United States against a missile that could come from the far east or the far west. And so to make something like that work, first you have to have satellite sensors that are watching everything so that you can detect a launch. And once that launch is detected, then you've got a whole network of radars spread across the country and the world and in the ocean and on land, that their job is to detect that incoming threat and then start tracking it. And if you think about it, that incoming threat, let's just take a single example. That threat has a nuclear warhead. Some of them have multiple nuclear warheads. And once they get out of the atmosphere, then they pop off those nuclear warheads.
This is sounding worse and worse.
Yeah, well, and so when they do that, there are straps and bolts that come off, debris. There's chuffing out of the motors. And some of them have what we call decoys, things to confuse. And there are multiple different kinds of decoys. There's lots of little things you put out just to get high traffic, and then there's things that you put out that look like an RV, a reentry vehicle, the nuclear warhead itself. And so you've got all this stuff to deal with all these radars. And you track it, you've got to figure out what's in there, how many real things are in there, and how many of other things that you don't want to deal with. Then you've got to track it, get it very accurate in order to launch one of these interceptors, launch it up, and then after a while it will open up, it's got an onboard sensor, and it will detect this target complex, and it's generally told, we think, the radars, we think that's the real guy and these things are not, but you decide based on what you see. Now you're a lot closer. And then it has to discriminate it, pick the right warhead, and then it's closing at like 20,000 miles an hour. Very fast.
On something that is moving.
Oh, it's
really
moving
fast.
and you're
Yeah,
moving.
yeah.
And then when it gets really close, which doesn't take long, then it has to pick a point on that object to actually hit. And all this has to happen in something like 20 minutes. So from the time somebody launches to the time you've got to destroy it.
So you're actually, like the detection system, the radar, you're wanting to detect it while it's on the ascent, correct?
Well, you want to basically to wake up the system.
Yeah.
Now, there are other things that we have going on that
Yeah.
if you miss that, it's okay. We got some
Yeah.
backup plans on that. But that's the nominal scenario. And so you can see from a systems engineering standpoint, I like to say, the designers, they know a lot about their particular area, and they need to be deep.
Yeah.
But a system engineer knows a little bit about a lot,
Yeah.
because they have to balance all this. And there are various systems, like the interceptor itself is a system. It's got a sensor on it. It's got divert thrusters, so it can move around. And so the system engineer on the missile has to decide how much thrust do I need versus how much viewing distance do I need, and they have to balance all those so that if you left it to the designers, they're going to make it as good as they can.
Yeah.
And you may not need this part to be so good because it's really expensive. So back off on that a little bit and balance it with the other part.
Yeah.
And so that's the job of the systems engineer, is to come up with the requirements for each of the parts such that you get a balanced system.
Yeah. Okay. One question that just jumped in my mind. You said sometimes they have multiple warheads.
Yes.
What do you do with that?
Well, so if you have multiples, now you're going to be shooting more things at them.
Okay, so you're going to have to launch more interceptors.
Yeah, and so the balance is, let's say we have a case where just a single warhead threat is coming in. You've got all this other stuff out there. So you may decide, based on what I'm seeing, that one looks most like it, but this one could be it too, and maybe that one. So you're going to be shooting at things that you think are high probability being a warhead, because if one gets through, it's a bad day.
Yeah, I mean, it's like, Okay, GMD's been around for a while. I mean, the system, it's been operational for quite, how many years would you say?
2004, so.
Okay, so it's been operational.
21 years.
Okay, so when it was developed, I mean, you've seen the videos of the developing, like Saturn V, for instance, a lot of draftsmen, a lot of blueprints and all that.
Yeah.
Now, that's not the case for GMD, but I've got to believe the way the system, the development process was more primitive, is probably the wrong word, but a little more primitive than maybe the current model-based systems engineering.
Absolutely. It was more of the classical requirements and design reviews, and the model-based systems engineering had not come in until the last several years.
So doing that, so instead of, and I'm not an engineer, like everybody would not know that, but now with model-based systems engineering, everything's digital. The systems engineer in charge of something, he gets a modeler to fulfill requirements, and then he can see how it fits in with everything else.
Right.
When GMD was being developed, I bet that meant a lot of meetings and hashing out. Yeah, I know it would be a lot stronger if you could do that, but you can't do that because we can't. It's too heavy. We can't launch that.
Right.
So is that kind of how it was then?
Absolutely. And you'd have working group meetings where you'd get all the right parties in there, and then you'd do exactly what you said. You'd hash out and somebody say, hey, here's my great idea. Well, that won't work because of this and that.
Yeah.
So you go through that iterative process, and it was a manually iterative process.
That took a long time, didn't it, to get that done?
Well, it did and it didn't. So I say it didn't because we weren't given much time in the beginning. So in 2000, late 2001, early 2002, is when President Bush said, before the end of September 2004, I want a system.
Oh, that's one of those launching within the decade things.
And so, you get basically 2 years and there's nothing.
Yeah.
Nothing. The missile field in Alaska was a field. There was absolutely nothing. And so it was bring it all together. And on September 30th, 2004, we turned the system on. And we had 5 interceptors at that point.
How many interceptors? It's probably classified, but
No, it's not. 44.
44. Okay, so we've come a long way.
Oh, yeah.
Okay, so, in the beginning, I remember much was made over. There were tests, and some of the tests didn't work. I think Americans have lost sight of why you test.
Yeah, right.
You test to find flaws.
Exactly.
And so, because NASA runs into that, everybody,
sure.
everything blows up, means it's bad. You're failures. You spent all that money and didn't get it done. But testing, that's why you do it, to find out what doesn't work right.
Exactly, because there are some things that you just will not learn except in a test, because the environment, the situation is you can't replicate it. We had a case where one of the interceptors, when it would fire a thruster, it created a vibration environment such that caused some disruption of some electronics in the interceptor. And it turned out that particular environment we didn't have the ability to even create on the ground prior to be able to test it, even if we had a thought.
It wasn't even a question you knew to ask.
No, exactly. We didn't know that this was occurring, and nor could we have created it on the ground. Now, subsequent to that, we created some new science, and we created that environment to test it on the ground. But it was something you would have never known to even ask if we hadn't observed it in a flight test.
And that, and once again, you can look back at the Saturn V program, see the same thing.
Exactly.
They flew things with rockets with people on them, and that's a problem.
I didn't know this.
So
happens.
it's okay. So as the program went along, of course, you're doing systems engineers work for all the things you've done since that. You've been wrapping your arms around a program or a portion of a program the whole time.
Right.
The whole time you've been,
Yeah, in fact, the first job at Boeing, when I went to Boeing, I was the chief engineer on GMD for the first 5 years. And so I had my sphere of responsibility was all the engineering for the entire program.
Okay, did it get easier as people moved along the line of steps to what we refer to now as model-based systems engineering? Were there steps you went, okay, this made it a little easier? I'm still having to have a meeting with you to find, but has it gotten, or did it get easier as you're moving along?
It does, because a lot of the things that were more manual and checking, when you are manually checking these things, you can miss them, first of all, but it just takes longer. And now the model-based systems engineering automates a lot of that, where it will be more error-proof, as well as it's much more efficient in terms of checking things.
Okay. Is it fair to say you weren't necessarily on the development end, you were on the this doesn't work, we've got to figure out why end? Or how would you describe what you did in years with GMD?
Well, we were developing and producing and fielding and testing and improving, and so we went through. We had it's the first few years on GMD when we were putting out the first system. we would have like 3 different system improvements ongoing at any given time. One that we were fielding, one that was the next one to be fielded, like in a few months.
Yeah.
And then it was in its final ground testing activity, and then another one that was in development that was just beginning testing, and then another one that was the development for the next generation after that.
Okay, so your systems engineering was paying attention to those 3 aspects
Yes.
that had their own systems engineers.
Right.
Is that a way to look at it?
Yep, exactly.
Okay, so
Exactly.
how were modelers involved in this?
Oh,
at this
yeah.
point? So
Oh, yeah.
So were the modelers at that time? And I guess when modeling started, the modelers they weren't modelers; they were systems engineers doing modeling. Is that the way to say it?
Yes, I think that's a
Okay.
really good way to say it. And you had them at different levels, just like systems engineers down to the design engineering. So you had design engineerings that were modeling things. You had the systems engineers that were overseeing what the different designers were doing and making sure all that's coming together. And for the next generation to be designed, they were helping establish what the requirements were for those designers so that they would know here's how good to make this part and here's how good to make that part so they'll fit together just right.
Could each of the systems engineers see everything at some point in the process when you were there? Could they see everything without having to have a meeting, or did they still have to have meetings?
Yeah, I don't know that you could have done it without having meetings to get the right people together, and communications is difficult. You can write a requirement.
Oh, by the way, let's just stipulate everybody wasn't in one building.
No, we were so GMD was spread out across the country. We had thousands of people, and dozens of companies.
Yeah.
So we had people spread out almost in every state, and so just getting people together, even virtually. Back then, it was harder because
the Zoom thing wasn't. Well,
Exactly.
but I remember once upon a time, and the beginnings of what is now the Zoom meeting, like on the Arsenal, they had auditoriums.
Yes.
With big TVs,
Oh, yeah.
and there would be a guy,
Video
and they would have basically TV shows, communication
Exactly.
by TV.
Yeah, we had that.
And I remember also going in the office for GMD out on the Arsenal, and I think it was General Holly at the time. Big televisions. One of them was Greeley, Alaska.
Yep.
And those were the initial interceptor sites. Right.
That's right.
So, so that part of the development has come a long way.
Oh, yeah.
And it was better than the early missile and rocket days when you had to get on an airplane, fly to California.
Right.
You could or fly to Alaska.
Yeah.
Although some of that still happens.
Yeah, and it's a bit more complicated even back then when we had the video teleconference, because most of what we did was classified. So you couldn't just do like a Zoom call like you do now.
It had to be encrypted.
You had to have a certified, classified video teleconference system so that you could get.
So it's obviously easier now.
It is.
So when you were still at Boeing, had y'all moved into? Were things entirely digital? How long have you been retired? I guess we need to stipulate.
4 years.
4 years.
So we were doing a lot of model-based systems engineering at the time. It certainly was not entirely digital. Now we had a few programs that were.
Yeah.
When they, new programs when they started, we tried to take the opportunity. Let's go all digital on this one. It's a lot more difficult with a mature program to feed that all in.
Is it more difficult because you have to take all the aspects and make them digital, or is it more difficult because some of the people who've been working on it for a while aren't familiar with doing it that way?
It's some of both, but it's also, and you've got to stop. You've either got to have a separate group to go do that, or you've got to stop what you're doing and go do that, and basically stop the program. And so, and you can't stop the program in general, And to have another group go do this, that costs money. And unless that's part of the contract, which in many cases now, some of the programs are the government is saying, hey, I want to go model-based systems engineering on this, so let's go start this activity.
Okay, and what you said, that's one thing we talk about a lot here, is that it is a requirement, but it feels sometimes from what I hear kind of a semi-requirement. Yeah, you're supposed to do that, but it feels sometimes like there's some pushback from some companies who haven't just we don't really want to do that. Am I saying this correctly?
I think so, and I think it's more of because it's new and it's different, and I don't really understand it. So I know the old way. I know what I'm doing here, and so if it's not broke, don't fix it.
Yeah, but you've seen it, so you should fix it even if it isn't broke, shouldn't you?
It is a tremendously much more efficient approach. And so from that perspective, it's hard for people to see that don't understand it or don't quite get it until you see it happen. And then when you see it happen and you see the value in it, that's when it clicks.
Okay, what is the value in it?
Well, as I mentioned, it allows you to, rather than doing things a manual way, there's a dramatic efficiency improvement.
Okay.
And you won't miss things. When you're doing things manually by hand or by person, things fall through the crack. And as long as you developed your models accurately, then that is a safety net to keep things from falling through the crack. And then as you're looking at what ifs, you can do the what ifs in the model, and they will tell you, hey, I'm thinking I want to do this, twist this knob here, and you can see the effect in the entire system.
Yeah. Okay, so you said back in the day, not that long ago, you had systems engineers actually doing the modeling. Well, now there are modelers, folks getting out of Calhoun Community College in Wallace State, and hopefully lots of other community colleges around the country in the near future. And they go to school to learn how to model. What do you think about all that? I mean, have you had a chance to work with any, modelers who weren't engineers, they were modelers?
I haven't. The programs that I ran before I left, we had some that were doing a lot of model-based systems engineering, but at the level I was, I didn't get a chance to interact a lot with those. So I haven't had a lot of experience with that.
Okay, you never know.
But
what do you think?
But
about
that said,
getting on a computer and modeling
it doesn't matter.
Yeah, it does.
As long as they know what it is they need to do, and they can ask. It doesn't matter what they are. If they can develop the model that fits into the overall systems engineering construct, and
there are plenty of companies doing that.
Yeah.
So doing that, and I've talked to several of the people working with modelers, and they love it. And you mentioned money a while ago about something being expensive. Well, in this day and time, things are not getting cheaper.
Yeah.
But a 2-year degree to be a modeler, that's cheaper for the student learning to be a modeler, but it's also cheaper for the company. You hire somebody, they still get paid well because they've got an important job, but you don't have to have a full-fledged engineer. That's kind of
and you don't need one for that.
Yeah.
I mean, you that is your expertise, and you know how to develop the models. And if there's an engineering question, you can always ask that. But there's no need for you to have that knowledge. What your knowledge needs to be in is the best way to do these models.
Okay, so you're an engineer. You've been an engineer. You've worked on a lot. Does the current the systems that are becoming more and more the system, does that excite you? Do you think, oh man, I wish we had that back in 2001?
Oh yeah. I mean, things are advancing at a phenomenal rate in some areas, and AI, for example. I look at some of the stuff now, and it's like, wow, I wish I'd have had that back in the day. It would have made things so much quicker and so much more rapid to be able to do things.
And how does that fit in? So you've got modelers, systems engineers. Is it even a question I can ask about how AI would fit into that process?
Oh, sure. For example, there are AI tools out there that you can basically input, hey, here's what I want. Give me that. And it will come back and give you that. Now, that doesn't mean that you're not going to tweak it a little bit, but 90% of the grunt work has been done, and now you're taking your expertise and you're fine tuning.
Okay, so it's like doing. You don't have to stop and do the calculations. AI is doing the calculations for you and speeding things up. Okay, the system that appears to be the future, and that would be model-based systems engineering. It's the future. It's not. It's the present for many companies.
Yeah.
And it is likely, I would expect at a certain point, there's a tipping point and you're either doing it or you're not getting the work. So are we approaching that, or is that something we have in your mind?
Yeah, I think there's still a ways to go, and it's really overcoming the, we know what we've been doing and it works, but it is kind of like, a couple of steps well beyond that of improvement. And I think there are some that are doing it and some that are saying they're doing it or thinking about doing it. But I think, to get fully there is still got a ways to go.
You expect, though, that it's going to get there.
I do. And, a lot of it, we're in this transition period, like I said. You've got programs that have been going on a while, and so those are going to be much harder to unless they have like a pre-planned improvement, a design iteration where they can take the opportunity and go do that. New programs, that's the ones that really.
So you almost have to go digital, go entirely digital and model-based systems engineering on those, because that's. And one last question, it's kind of a joke, and I've heard other people say it. You can do things, cheaper, faster, better.
Yep.
But you can't do all three of them at the same time.
Yeah.
But
cost, schedule, and performance. Pick any two.
So does model-based systems engineering get you closer to being able to do all three?
I think it does. Cheaper. There's going to be a cost advantage if you can get these models developed correctly and accurately. You are going to save a tremendous amount of time, which is money. Schedule. Now you get to quicker schedule, and any changes are much quicker. You can see the effect of them through the models, and better. It's as I mentioned earlier, you get the built-in error proofing of it because the models are doing the checking and they're much less human error prone.
Okay, so you're not doing any consulting, are you?
No.
Okay, but say you were a consultant and a company that's considering moving wholeheartedly into model-based systems engineering, hiring modelers from community colleges and to work under their systems engineers, and they say, Norm, should we do this? What would you say?
Absolutely. And get somebody who has done it to help you. Because if you just go you're going to have to learn all the lessons that somebody has already learned. And there are some companies some smaller companies that have developed tools. They've helped some of these big prime contractors. At Boeing we have a small company that we're going through transitioning GMD. Even though it's a mature program, one of the tasks that Boeing has is to evolve that into a model-based systems engineering. And so we've got a small company here in town, or they do, that are helping them with that. And so that is crucially important, I think, is to don't just start afresh and say, hey, I think I'll do model-based systems engineering once I figure out what that is.
There's people to help you figure it out.
Yeah, and they've gone through, they've got the scars, they've figured out what to do, what not to do, how to do things, what the benefit is. And as I would also encourage, if there are managers out there that are saying, yeah, I don't know if I want to do this, go talk to some people who have done it and ask them, show me why I should do this. And they will show you examples and use cases of here is why, here is what the value. And once you see some of those tangible examples, you start to say, ah.
Wow. Well, Norm Tew, thank you so much for being on with us.
You bet.
I feel smarter.
I don't know about that.
That's not all that hard. So anyway, and thank you for being with us. And Norm Tew, a legend in the engineering world in Huntsville, Auburn grad, War Eagle.
War Eagle.
All right. Thank you for being with us, and remember, it works.